All right, let's take a look at the homework. So it was 118, 119, right? Was there any question? Let's see. We are writing the equation of the slope-intercept passing through the points, right? So that's not really, I mean, you should be fine with that, I hope. It's just slope. And then problem number 2, so 1 through 4 you're fine with, yes? Problem number 5 says, write the equation of your line in slope-intercept form. Use the line to calculate when a certain value is 20. And a certain part when x is equal to 5. Okay, let's see if we can make this one work. Okay. All right. Is that gonna work for me? Maybe. Oh, man, it's working over here. It's on the computer. There we go. All right, cool. Did I draw that? Whoa. Cool. All right, we're in the fancy pen. All right, let's go to regular pen. There we go. That should work. All right, so write the equation and the slope. So we have this linear equation given. And we have some points that are on it, correct? So we have one out here. And let's see, that's down a little bit, one right there. And then kind of that, right? There's more points that we've drawn. So they did give us some values. We have -8, -3, -6, -4, 1, so on and so forth. If we were to draw a line of best fit that works here, you have some sort of line of best fit that you draw in. I think everyone's pretty solid on that. Do you think when I'm testing a problem that I'm trying to determine if you can draw a straight line? No. Or do you think we've passed that standard in school? I think we're probably past it. But, so now you just have to pick 2 points. So I'm just going to pick 2 of the points that I think like maybe -6, 0. That was on our grid. And I think maybe 6, 9. Would that be okay if I chose those 2 points? Okay. I just chose from the list. I didn't put a whole lot of scientific thought into it. Okay. So from there it says write an equation. So the first thing. Oh, and I saw the test. We give you the slope equation. So for those of you who are like, it's overrated for me to memorize. Oh, okay, good. So let's see. M equals 0 minus 9, -6 minus 6, -9 over -12. So I have a slope of 3/4. Is that okay? Based on my points, you might have had a little bit different slope if you chose 2 different points, but it's relatively close. Let's find y minus y1 equals m times x minus x1. So let's see, I got y minus 0, I'll use this one, equals 3/4 x plus 6. Y minus 0 is just 0. If I distribute this here and here, so I get 3 over 4x. 3 times 6 is 18. 18 over 4. 18 over 4 reduces to 9 over 2. Is that okay? So our line of best fit is y equals 3/4 x plus 9 over 2. So that would represent this line of best fit in my case, being I chose those 2 points. If you chose 2 other points, your line of best fit might be off a little bit from mine, which is okay. Calculate x when y equals 20. Okay, so let's extend the page down a little bit. So calculate x when y equals 20. So think about what this would look like as a point. Do you agree with how I have that represented? Yeah. Okay, so I'm looking for an x value. So what is this 20 going to plug into on our equation? X or y? Y. It's going to go for y. Good. So I have 20 is equal to 3 over 4 plus 9 over 2. I might choose to clear the denominator. That's a term we haven't used in a little bit, but I think we could do it. So let's multiply everything by 2. So this becomes 40. Actually, and yeah, that'll be okay. No, let's do this. Let's not do 40. Let's multiply everything by 4 because of the bottom denominator. So that'll be 80 equals 3x. If I multiply that by 4, that becomes, reduce 4 over 2, let's choose 18 plus 18. Subtract 18. 80 minus 18 is 62 equals 3x. So x is going to be equal to 62 over 3. What point is that? I don't know, 20 2/3? Yeah.
I'm confused how you got 9 over 2.
When I distribute it here, 3 times 6, that's 18. 18 over 4. 18 over 4 reduces 10 over 2. All right, the second question says, calculate y when x equals 5. So x is equal to 5. We're now calculating the y. Okay, so I'm going to take this 5, and I'm going to plug it into my x value. So I'm going to plug it in right there. So doing a little bit of math, 3/4 times 5 plus 9 over 2. Do the arithmetic. It'll figure it out. Okay. And then problem number 6, we're going to do the same thing. Look at the equation, interpret. And then it talks about November 29, 2010, water that's flowing out of Dillon Reservoir, okay, which is up in the mountains. Label the x and the y axis appropriately. So this is problem number 7. So I would need to put time and days here. And then the other one is cubic feet per second. Okay. All right. So we'd have to create a scale. So it looks like 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then it goes from 26 to 34. So I could probably count by 5s. Cool. All right, so let's plot our points. So the first one is 0, 26, right there. Our next day is 1, 28, right here. Our next one is 2, 29, it's right here. Our next one's 330, 433, and 534. Line of best fit. Something like that. Seem okay? So we would have to pick 2 points to find the line of best fit. Write the equation for your line. I don't know. I got to pick 2 of the points that seem pretty close. As far as mine goes, it looks like they all kind of work out nicely. So maybe I'll pick that point, and maybe I'll pick that point. So 0, 26, and what was 5? 5 comma what? 34? So you can find the slope. So 34 minus 26 is 8 over 5. So the slope in the context of this problem means the flow of the river is 8 cubic feet per second for every 5 days it's flowing. Oh, yeah. So it's increasing. It's going faster. Okay, thank you, though. I could make that error real easy. Let's figure out our point slope. So I'll use this as, so I'm going to go y minus y1, which is 2 to the 26, 8 over 5, x minus 0. So if I distribute this, I get 8/5 x and 0. So if I add the 26, that's our line of best fit. What does y represent? That's the cubic feet per second the river was flowing when we got there. We walked up, hey, look, it's going 26 cubic feet per second. The slope in the context means that it's flowing at 8 cubic feet for every 5 days. So it's increasing 8 cubic feet for every 5 days. And use your line and estimate how many days. 40 feet per second, bless you. So if I was going to do the 40, I'd plug a 40 in right here, so that's a y component. So plug it in and solve it. And then the x, same thing. We wanted to find after 8 days. That's an x component. Plug it in right here, and you'd solve it. All right, let's get to the nitty-gritty. If you have a graphing calculator, please have it out. If you don't have a graphing calculator, you can borrow one of mine during class, but you can't take this home. Okay? So if you need to borrow one of these, I have 10 of them. 3, 4, 5, 6, 7, 8, 9, 10. When they're gone, they're gone. And it's so I'm not quite sure what part of you need one of these for class is not being comprehended, but they're out, they're out. You're required to have one. That's
Mister, I'll have one, but I forgot it. I mean, I know how to use it though.
sweet. Yep, that's part of it, yeah. All right, let's take a look at our notes. All right, so this seems like it'll work. And my emulator's up. Okay, analyzing, this is notes, analyzing lines of best fit. This calculator is a pretty powerful tool for you. No way, shape, or form am I going to make you a master of it by 20 minutes from now. Okay? No way, shape, or form. So there are a lot of really great things that it'll do. I will try and walk you through it, being that I have some 83s in here and I have some 84s in here. And some of the functions might be a smidge different, but we have to walk through it. So I'm going slow through this so you can find what keys. Again, 20 minutes is not going to make you a master of it. All right, so first thing, a statistics student wondered if she could predict the number of people that would be at a neighborhood pool based on how warm it was that day. She tracked the attendance for several days and obtained the following results. Okay, so let's get rid of this. All right, so we have to determine the x values and the y values. So would it be okay if we called the x values temperature, the y values the number of people?
Yeah.
Seem okay? Okay. Everyone's still saying, have we done anything on the calculator at this point? No. Then we're going to go to list, clear list, and do that. So what I'm going to do now is I'm going to walk you through how to clear a list on a calculator. There's a few things. If you're borrowing my calculator, those might have been used by other people for other times during the day. Yes? So they might not have cleared everything out. So item 1, let's turn the calculator on. The on button should be in the lower left-hand corner. Okay? So if you have anything on your screen, you can hit clear. Mine's going to look somewhat similar. Let's see if I can do this on there. All right, so first thing I want you to do on your calculator, I don't don't want any of our graphs to be on our screen. Any old graphs. I don't need it. Okay? I try to go through the yellow ones and clear all of them out. So first thing you're going to do is just go hit y equals. If you have things in there, so let's say this had some equation in there. So I have that in there under my y1. I just go to y1, I just hit clear. Get rid of it. Use your arrows to take you to wherever you need to clear that. There should be up to 10 graphs on most. Some of the calculators might go up to 20. It just depends. Make sure you don't have anything under that. So that's just getting rid of the information that you don't need. Okay? All right, so let me go back, take a look at my notes. What we have so far. Go to XY values, go to list. Okay, clear list. L1, okay, here we go. So we're going to start plotting our data on our calculators. The calculator, as soon as you put something in your calculator, it's going to stay there as long as it's there, unless you clear it out or that. So first thing you want to do is you're going to, let me see, hit stat. Yep, hit the stat button, S-T-A-T. And we want to edit. Now, before we get to edit, don't go start putting anything in. There's things that you can do that can delete out, and I can put it back in, but it becomes a pain because you're like, oh, I was pushing every button, I didn't know what to push. See the stat button? Push that. Okay? We want to edit, so hit number 1, and it's going to take you into something that might look similar to that. Don't go plug anything in yet. So this allows you to put slats of data in. Right now, list 1, L1, is going to represent our X values. I did what?
No, just look. It already has stuff written.
Okay, if you have stuff already in there, so let me add stuff to mine. Let's say you have stuff in there. You take your arrows, you go all the way up to the top, you hit clear, and then the down arrow. Clear, and the down arrow. So if you had stuff in there, okay, you go to the very top using your arrows to L1. You can also move over to L2 if you needed to, and you hit clear, and then the down arrow, and it's going to get rid of the stuff.
What if you want to delete a specific number?
Let's not worry about that point. Not at this point. Did you add something in on a list already that you need to get out of? Let's see. So let's just explore it. Let's say I have 8, 9, and 5. And let's say I want to get rid of the 9. Let's see. If I go here, can I hit clear? Nope. I might have to hit delete. Nope. Yep. Yeah, if you hit delete. So that'll get rid of it. But don't hit delete when you're up here. Do not hit delete up here. It's going to do things. Yeah. All right. Thank you. All right. All right, I want to plug in my data. So for temperature, that's my X value. I'm going to plug in the following. So I have 80. And each time you plug something in, hit enter. 80, 82, 83. Does this make sense what I'm doing?
Are you putting all the X values?
Yep. Put all the X values in first. 83. Oh, crap. My trifocals suck. 84. 86, 87, 88, 89, Once you get your whole list in there, it looks like, what, 14 numbers? Look at 15. Oh, I forgot 96. Looks like. So you can use your arrow over to go to L2. L2 is going to represent our Y values. Our Y values are the number of people. You want these to match up. So with your 80, you have 121. If you make an error, you can use your arrows to get in there. Just hit enter to move down. 20, 26. hopefully your data matches up. If you found you made an error someplace, just arrow to wherever you need to and just replace that value. Okay. Did everybody get their values in? Yes. I'm not asking you to go any further than this. I just want to make sure. Did you get your values in on the calculator? Yeah. Is all okay? Get them in there? It's all worked? Anyone stuck? May I move to the next section? So list 1 and list 2 are acting as ordered pairs. Whatever is in list 1, row 1, and list 2, row 2 is your ordered pair. So it's a point. Okay? So let's see what our next page says to do.
It says now find the equation of your line of best fit.
So get the regression equation. All right, so then you can just go right there. So determine your x value, y value. We did. Hit the stat button and hit edit. We did that, yes? Clear all the data in L1 and L2 columns by arrowing up until L1 or L2 is highlighted, and then clear. Don't clear it down. We just added stuff. Enter your x values into L1, your y values into L2. Step 5. Now find the equation of the line of best fit. Go to stat, then calculate, then linear regression. Oh, but before we do that, I want to see what our information looks like. All right, so everyone has their data in, yes? Is anyone stuck? All right, we need to tell the calculator that we would like to plot our data. It's not just going to plot it right now. You know, a lot of times it's like, oh, sweet, if I hit graph, wait, there's nothing there. Right, there's nothing there for a reason. So don't do it. I just want you to see this on mine. If I hit graph, I get a -10 to +10 grid. Agree? So I need to tell the calculator I want to turn it in. So what you want to do is you're going to hit second y equals. Second y equals. Second's up at the top left. Y equals is above it. This is going to allow us to turn our stat plot on. Okay? We'll take care of number 1. And then it's going to go in. So notice it's blinking on the on. If the off is bolded like that, that means it's off. So hit enter. So we're going to turn it on. Enter. I don't want these fancy looking graphs. I just want dots. Okay? I want list 1 and list 2. And then we can choose our mark. Do we want a square, a plus, a bigger dot, or a little dot? It doesn't matter. Okay, you pick the one you want. And then mine's defaulting to blue. Some of your calculators won't default to a color. If you have the TI-83, it won't have a color for you to choose from. It might only have a square, a plus, and a dot. It might not have the 4th option of the smaller dot. So don't worry, it's not going to goof things up. All right. Does your screen look like this? Okay, so if I hit graph right now, because I know most of you are going to get excited going, but it's not there. So I told you this is a -10 to +10 grid. Agree? My data starts at 80 and goes to 96, starts at 121 and goes to 145. So I'm going to do this. Ready? I'm going to go to zoom, top middle, and I'm going to go to zoom. I want zoom stat. Zoom stat. And boom. Hit zoom. Because you have your columns aren't matching up. Look at this. I go down this one. I'm missing the values. That's what my data looks like if I graphed it. The calculator with zoom stat makes the window on the calculator make it a window that is appropriate. Okay? Ready? So, if I go to, I hit stat one more time. And I go to calculate. So use your arrow over to go to calc. You want to hit a linear regression, which is AX, which is number 4. And sometimes it's a little different. Yeah.
I just like kind of dropped mine and it just fell on my lap and then went to a blank screen. So I don't know if I just like hit a button.
Okay, so hit zoom stat.
Zoom, stat,
Yeah, but enter.
enter. Okay, okay.
Cool. Yeah.
And I go like,
Mine's also messed up. It like went back to all.
Hit zoom stat.
yep, okay.
Do you see the picture?
No, just edit one.
You turned all your plots on.
I turned on my what?
You don't have all your plots on.
Wait, how do I get to that?
Your data's off. You have one more piece of data and one more column, so it didn't match up.
Wait, that's mine.
I saw this.
What? Why did you do that? Oh, I did that. What are you saying? I got the same thing, but like opposite.
All right. Now, I'm going to turn one thing on my calculator. Don't worry about turning yours on at this moment. Do it, or let me just ask you this. Has everyone got to this point? Are you, if you're at that point?
No.
Okay?
No.
So let me walk back through how I got there. I hit stat. Still with me?
Yeah.
I hit calculate, so I move my arrow over to calculate, and I want a linear regression, which is number 4.
Oh.
And then I arrow down to calculate, or I could hit enter, enter, enter. Hit calculate, and boom.
There we go.
Enter. So some of you might have an R value and an R squared value down here, which is kind of cool. Okay, that's the R value is your correlation, meaning it's positive or negative. Remember yesterday I said if it's closer, if it's negative, if it's closer to -1, the more exact it is. Closer to +1, the more exact our graph is. Depends upon if our data is. So I'm going to turn mine on real quick. So it's under diagnostics. So notice I have that as well. So R squared we're not worried about too much right now in Algebra 1. R is what you're worried about. R being 0.945. That's like getting a 94.5% on a test. Is that pretty good? Being there's like 3 of you that have established that kind of grade so far in the class. Those are the A's. Okay, so is that good? No, I'm happy with a 21%. Good for you. Okay? So, that R value is a good thing. Okay? The closer it is to 1, 1.00 is a good thing. Again, this is like saying I have a 94.5% on a test. That's pretty great. Okay? So, if I go back to my slide, again, I said we weren't making ourselves perfect, right? So let's take a look just at our correlation. We have a perfect positive correlation, means it falls on a nice straight line. So that would be an R value that would be really close to 1.00. This one's pretty good. This is like 0.93 or something. Weak is like 0.70 something. No correlation, it's really close to 0. Weak negative correlation, it's a negative because it would have a negative slope. Stronger, like a negative 0.93. And a perfect would be like a negative 1.00. Okay? So that's just what those R values mean. You want your R value to be really close to positive 1 or really close to negative 1. Okay? That means your data's good. All right, so a statistics wondered if we could do this. Okay, this is the data we have in there. What is our line of best fit? Well, we already found it. 1.55 is my minus 3.95. Yeah.
I have a question.
Talk to me.
Why couldn't you just draw like this graph? Why can't you just do this like on a piece of paper?
You can.
And make your own graph?
Well, you can.
Harder.
What if you had 10,000 pieces of data?
I mean, a piece of data can't go on.
And your calculator could.
But what test would they give us 10,000 pieces of data?
Not in Algebra 1. So again, I told you I wasn't going to master you on this in 20 minutes, right? So it's introducing it to you. So there's no way, shape, or form that you would be a pro at it.
Is today the only day you'll know?
No. All right. What does the slope mean in the context of this problem? What does 1.55 mean? It's 1.55 over 1. What is my y component? What is my y component? Number of people. What is my x component? Temperature. So 1.55 as a slope means this. There's 1.55 people that add to the pool for every 1 degree it increases in temperature. Does that mean we have a part of a person? You have some guy who's coming in missing legs, needs less than a person? No, this is just the rate of what people are coming into the pool. So we are adding 1.55 people for every 1 degree to go up. What does the Y-intercept mean in the context? This is kind of weird. It's negative 3.95. Y-intercept, Y is the number of people, agreed? So if it's 0 degrees outside, guess what? There's negative people at this pool. Does that make sense in the context of this problem?
Aliens.
Yeah. So we can't have a negative person. We can't have people leaving. So what does the slope mean? We are adding 1.55 people for every 1 degree warmer. What does the y-intercept mean? At 0 degrees, we have negative 3.95 people at the pool. That's weird. What does the correlation mean in the context of this problem? I don't know. What are our R value?
Oh.
My R value was 0.9455. It means we have a pretty good, strong, positive correlation. It means that this seems to have some sort of relationship to it, which is pretty cool. Okay, so we have that. We have 2 more slides. So I have to actually go back to these 2 slides on Monday. So this is what I think we should take a look at. So the graphing calculator, no. So page 120 is what we will have due for Monday. Okay? If you borrowed one of my calculators, item 1, make sure there's batteries in it and bring it up to my basket, please.